Right now, someone is moving a mountain. Literally. And it's not even the craziest thing happening on this list. While you're watching this video, there are construction projects happening across the globe that make the pyramids look like a weekend DIY project. We're talking about structures so massive, so expensive, and so technically insane that they're redefining what humans can actually build. Some of them will change how entire continents trade. Fun times. So buckle up. We're about to tour 8 mega projects that are either going to reshape civilization or become very, very expensive mistakes. Let's find out which number 8. Saudi Arabia. Imagine a city that's a straight line, not a sprawling mess like Los Angeles. A literal line, 170 kilometers long, 200 meters wide, and 500 meters tall. 2 parallel mirrored skyscrapers running through the desert with everything you need sandwiched between them. That's the line. And yes, it sounds like someone pitched a concept from a sci-fi movie to a government with unlimited oil money. Because that's basically what happened. Saudi Crown Prince Mohammed bin Salman unveiled this fever dream in 2021 as part of NOAM, his $500 billion attempt to diversify Saudi Arabia's economy away from oil. The idea? 9 million people living in a car-free, carbon-neutral megastructure where you can access everything you need within a 5-minute walk. High-speed rail underneath gets you from one end to the other in 20 minutes. The whole thing is powered by renewable energy and surrounded by nature reserves. Sounds utopian, right? Here's where it gets wild. The line is being built in one of the harshest deserts on Earth, where summer temperatures regularly hit 45 degrees Celsius. The mirrored exterior is supposed to reflect heat, but engineers are basically asking, what could possibly go wrong with 2 170-kilometer-long mirrors in the desert? Spoiler alert. A lot. The environmental impact alone is staggering. They're not building around the landscape. They're cutting straight through it. Mountains are being demolished. Entire ecosystems are being relocated. And the local Hawitat tribe, let's just say their relocation hasn't been exactly voluntary. Human rights groups are having a field day with this one. Construction started in 2021, and they're aiming for the first section to be complete by 2030. That's right. They want to build a 170-kilometer-long vertical city in less than a decade. For context, it took New York City about 400 years to get to its current state. The line wants to do it in 9. The budget keeps climbing. Originally $500 billion. Some estimates now put it closer to $1 trillion. That's more than the GDP of most countries. And here's the kicker. The project's ambitions keep shrinking. Recent reports suggest they might only complete 2.4 kilometers by 2030, not the full 170. That's like promising someone a Ferrari and delivering a skateboard. Will it work? Ask me in 2030. The line is either the future of urban living or the world's most expensive architectural middle finger to common sense. Number 7. The Grand Ethiopian Renaissance Dam. Let's head to Africa, where Ethiopia is building what will become the largest hydroelectric dam on the entire continent. The Grand Ethiopian Renaissance Dam, or GERD, sits on the Blue Nile in northwest Ethiopia. When it's finished, this thing will generate 5,150 megawatts of electricity. That's enough to power about 5 million homes. For Ethiopia, this is huge, literally and figuratively. Around 44% of Ethiopia's population doesn't have electricity. This dam could change that. It's a symbol of national pride, economic development, and energy independence. They're building it with their own money, about $4.8 billion, making it one of the few mega projects in Africa that isn't drowning in foreign debt. But here's where things get spicy. The dam sits on the Blue Nile, which eventually flows into Egypt. And Egypt is not happy about this. Like, really not happy. The Blue Nile provides about 85% of Egypt's water supply. So when Ethiopia started filling the dam's reservoir in 2020, essentially reducing downstream flow, Cairo went into panic mode. Egypt's position is simple. They've had water rights to the Nile since a 1959 agreement with Sudan. Any major project on the Nile needs their approval. Ethiopia's position is equally simple. That 1959 agreement was made when they were never consulted. And they're not about to let a 63-year-old colonial-era treaty dictate their development. Sudan is caught in the middle, sometimes supporting Ethiopia, sometimes siding with Egypt, mostly just hoping nobody decides to solve this with tanks. Construction started in 2011 and has faced every obstacle imaginable. Technical delays, political disputes, assassination attempts on engineers, you name it. The dam was supposed to be finished by 2017, then 2023. As of now, it's about 95% complete, with the final turbines expected to come online sometime in 2024 or 2025. Maybe. Possibly. If everyone plays nice. The dam itself is massive. The main structure is 1,780 meters long and 155 meters high. The reservoir behind it, when full, will hold 74 billion cubic meters of water. That's roughly equivalent to the entire annual flow of the Blue Nile. Filling it takes 3 to 7 years, depending on who you ask and how much they want to terrify downstream neighbors. The international community is watching this closely because GERD could set a precedent. If Ethiopia succeeds in asserting its water rights over colonial-era treaties, other upstream nations might get ideas. There are 11 countries that share the Nile Basin. Things could get complicated fast. But for Ethiopia, this isn't just about electricity. It's about sovereignty, dignity, and proving that African nations can build world-class infrastructure without waiting for permission from former colonial powers. Whether that message comes at the cost of regional stability is the multi-billion-dollar question. Number 6. Istanbul Grand Airport. Turkey decided that having one of the world's busiest airports wasn't enough. So they built a new one. And they didn't just build a new airport. They built the airport. The one that makes other airports look like regional bus stations. Istanbul Grand Airport, also called Istanbul Airport, because apparently Grand was too humble, opened in 2018, but is still under construction. This beast will have 6 runways and handle 200 million passengers a year. To put that in perspective, Atlanta's Hartsfield-Jackson, currently the world's busiest airport, handles about 107 million passengers. Istanbul wants to almost double that. The airport sits on the European side of Istanbul, about 35 kilometers north of the city center. The location was chosen specifically because Turkey wants to be the global hub connecting Europe, Asia, and Africa. Istanbul's geographic position is perfect for this. You can fly from here to anywhere in the world, and most of those destinations are within a few hours. But building this required some serious geographical gymnastics. The northern forests of Istanbul, a vital green lung for a city of 16 million people, got turned into tarmac and terminals. Environmentalists were not pleased. Protests erupted. The government responded with the construction equivalent of too late now. The main terminal building alone is 1.4 million square meters. That's bigger than any other airport terminal in the world. It's so big that they had to build an internal train system just to get passengers from one end to the other. Walking from the farthest gate to the exit could take 30 minutes. Pack snacks. Turkey invested about $12 billion into this project, which sounds like a lot, until you realize they're expecting it to contribute $50 billion annually to the Turkish economy once fully operational. The logic is simple. Control the travel hub. Control the money. Dubai did it. Singapore did it. Turkey wants in on that action. Here's the weird part. Istanbul already had 2 perfectly functional international airports. Ataturk and Sabiha Gökçen. Ataturk Airport, which was one of Europe's busiest, got shut down when Istanbul Grand Airport opened. Just closed. Now it mostly sits empty, a monument to the phrase "go big or go home." The airport also features some truly bonkers amenities. There's a museum, a library, prayer rooms for multiple religions, sleeping pods, a health clinic, and enough shopping to make Dubai Mall jealous. It's less an airport and more a small city that happens to have runways attached. Will it hit 200 million passengers? That depends on whether Turkey can maintain political stability, keep its economy from imploding, and convince airlines that Istanbul is the place to route everything. The first 2 are question marks. The third is looking promising. Turkish Airlines is already one of the world's largest carriers, and they're treating Istanbul Grand Airport like their personal playground. Construction continues on the remaining phases, with the full build-out scheduled for 2028. If it works, Turkey becomes the undisputed travel hub of the Eastern Hemisphere. If it doesn't, they've got a really big empty building in the middle of what used to be a forest. Number 5. Brenner Base Tunnel, Austria and Italy. But it might actually be the most impressive feat of engineering on this list. Deep beneath the Alps, Austria and Italy are drilling the world's longest underground railway tunnel. The Brenner-based tunnel will run for 64 kilometers straight through the mountains, connecting Innsbruck, Austria with Fortezza, Italy. Assuming they don't hit any more underground lakes or Roman ruins, it will be the longest railway tunnel in the world, beating out the current champion, Switzerland's Gotthard-based tunnel, by about 7 kilometers. Here's why this matters. Right now, about 2.5 million trucks cross the Alps every year, mostly through the Brenner Pass, which is the lowest and easiest crossing point. Those trucks create traffic nightmares, spew pollution into pristine alpine air, and occasionally cause accidents that shut down the entire route. The tunnel will shift most of that freight onto trains, cutting transit times and emissions. But drilling through mountains is hard. Really hard. The Alps are geologically complicated, a messy collision zone where the African and European tectonic plates are still shoving into each other. That means unpredictable rock formations, underground water sources, and constant risk of cave-ins. They started drilling in 2007. Two massive tunnel boring machines, affectionately named after saints, because if you're drilling through a mountain, you need all the divine help you can get, are working from both ends. They meet in the middle. Hopefully. If the math is wrong, they'll have two tunnels that miss each other, which would be embarrassing and expensive. The tunnel isn't just one tube. It's actually two parallel tunnels, each 8.1 meters in diameter, connected every 333 meters by cross passages for safety and ventilation. There's also a smaller exploratory tunnel that runs alongside, used for drainage and maintenance. In total, they're excavating about 230 kilometers of underground space. The cost? Around 10 billion euros, split between Austria and Italy. That's surprisingly reasonable for a project of this scale, mainly because both countries are really motivated to stop having trucks destroy their mountains. At its deepest point, the tunnel sits 1,720 meters below the surface. The rock pressure at that depth is enormous. The temperature can hit 40 degrees Celsius. Workers have to deal with heat, dust, and the knowledge that millions of tons of mountain are sitting above their heads. It's not a job for the claustrophobic. Water is a constant enemy. The Alps are full of underground aquifers, and hitting one while drilling can flood the tunnel in minutes. In 2011, they struck a massive water source that delayed construction by 2 years. The water table in some alpine villages dropped noticeably because the tunnel was accidentally draining their groundwater. Oops! But the tunnel is also a masterpiece of precision. When the two boring machines finally meet in the middle, they need to line up within a few centimeters. Considering they're drilling blind through dozens of kilometers of rock, that's like threading a needle while blindfolded and wearing oven mitts. Environmental groups love this project, which is rare for mega infrastructure. Moving freight from trucks to trains will cut CO2 emissions by about 60%. The Alps will get quieter, air quality will improve. Wildlife corridors will be less disrupted. It's one of the few mega projects where environmentalists and engineers actually agree. When it opens in 2032, trains will zip through the Alps at up to 250 kilometers per hour. The journey from Munich to Verona will take 2 hours instead of 5. And the Brenner Pass, which has been the main route through the Alps for literally thousands of years, will finally get a break. Number 4. United States. Speaking of trains, let's talk about the train project that refuses to die, no matter how hard America tries to kill it. If it ever gets built, we'll connect San Francisco to Los Angeles, with trains running at 350 kilometers per hour. The trip will take under 3 hours, compared to the current 6-hour drive or 1-hour flight, plus 2 hours of airport security theater. This is supposed to be America's answer to Japan's Shinkansen or France's TGV. A modern, sleek, high-speed rail system that proves the US can still build big infrastructure. Except it's been an absolute disaster from day one. Construction started in 2015. The original budget was $33 billion. The estimated completion date was 2020. As of 2024, they've spent over $10 billion, built exactly 0 kilometers of operational track, and the new cost estimate is somewhere between $90 and $128 billion, depending on who's doing the math and how much they're trying to sugarcoat it. Here's what went wrong. Everything. The route planning was a political nightmare. with every city demanding the train stop at their town, turning a simple San Francisco to Los Angeles road into a zigzagging mess. Land acquisition became a legal quagmire, with property owners suing left and right. Environmental reviews took years. Labor costs exploded, and California's political establishment couldn't decide if they actually wanted this thing or not. The current plan is to build a scaled-back initial segment in the Central Valley, connecting Merced to Bakersfield. Let me repeat that. They're spending billions of dollars to connect Merced to Bakersfield, two cities that nobody needs to travel between at high speed. It's like building a Ferrari that only drives in your driveway. The idea is that once this segment is operational, it'll prove the concept works, and funding will magically appear to extend it to San Francisco and Los Angeles. That's optimistic. That's California lottery winner levels of optimistic. If California can pull this off, it would be transformative. Los Angeles to San Francisco is one of the most traveled routes in America. About 40 million trips happen on that corridor every year. A functional high-speed rail system could take thousands of cars off the road, reduce emissions, and create a model for other U.S. cities to follow. The problem is that America forgot how to build big infrastructure. We used to be good at this. We built the Transcontinental Railroad, the Interstate Highway System, the Hoover Dam. But somewhere along the way, we got addicted to bureaucracy, NIMBY lawsuits, and cost overruns that would make a defense contractor blush. California high-speed rail is a test. Can America still build something hard? Or are we going to spend $100 billion and end up with nothing but studies, lawsuits, and a very expensive train that connects Merced to Bakersfield? The current estimate says the first operational segment might open by 2030. Maybe. Possibly. If literally everything goes right from here on out, which given the track record seems unlikely. But hey, at least we're trying. That's gotta count for something, right? Number 3. ETR fusion reactor. France. Now, we're getting into the truly insane category. The International Thermonuclear Experimental Reactor is humanity's attempt to recreate the power of the sun in a giant metal donut in southern France. If it works, and that's a big if, ITER will prove that nuclear fusion, the same process that powers stars, can be harnessed for clean, virtually unlimited energy. If it doesn't work, we've spent about $25 billion building the world's most expensive science experiment. ETR is a collaboration between 35 countries, including the US, China, Russia, Japan, India, South Korea, and the European Union. That's right. Countries that can barely agree on anything are somehow cooperating to build a fusion reactor. It's either a testament to human ambition or proof that scientists are better at diplomacy than politicians. Construction started in 2010 on a site in Cataract, France. The reactor itself is massive. The tokamak, the giant donut-shaped chamber where fusion happens, weighs 23,000 tons. That's about 3 Eiffel Towers. The entire facility, including all the support systems, magnets, and cooling infrastructure, covers 180 hectares. Here's how fusion works. In terms simple enough that I won't get yelled at by physicists. You take hydrogen isotopes, heat them to 150 million degrees Celsius, 10 times hotter than the core of the sun, and smash them together with such force that they fuse into helium, releasing massive amounts of energy. Easy, right? The challenges are absurd. You need to contain plasma at 150 million degrees, which is hot enough to vaporize any known material. So instead of physical walls, ITER uses magnetic fields to suspend the plasma in the middle of the chamber. The magnets are superconducting, meaning they need to be cooled to minus 269 degrees Celsius. So you've got something hotter than the sun just a few meters away from something colder than outer space. What could go wrong? Everything has to be perfect. The magnetic fields need to be precise to within millimeters. The plasma has to stay stable, which is like trying to hold Jell-O in a magnetic bottle. Any instability and the whole reaction collapses. Or worse, the plasma touches the wall, and you've just destroyed $1 billion worth of equipment. ITER's goal is to achieve Q greater than 10. That means for every unit of energy put in, the reactor produces 10 units of energy out. If they can do that, fusion power becomes viable. Not immediately practical, but viable. It proves the concept works. The timeline has been a moving target. Originally, ITER was supposed to achieve first plasma by 2016, then 2020. then 2025. The current estimate is 2039 for full fusion operations. That's not a typo. 2039. They started construction in 2010. That's a 29-year build time for a science experiment. The cost has also, surprise, surprise, exploded. Initial estimates were around $5 billion. Current estimates are closer to $25 billion, though some analysts think the final cost could hit $65 billion when you factor in all the delays and overruns. But if it works, if ITER proves fusion is possible, we're talking about a new era of energy. Fusion produces no greenhouse gases, no long-lived radioactive waste, and uses fuel that's abundant and cheap. There's enough deuterium in Earth's oceans to power humanity for millions of years. That's the dream. The reality is that we're still decades away from commercial fusion power, even if ITER succeeds. But somebody has to go first. Somebody has to prove it can be done. And if it fails, well, at least we'll have built a really impressive metal donut in France. Number 2. Beijing Daxing International Airport, China. You thought Turkey went big with their airport? Hold my tea. Beijing Daxing International Airport, which opened in 2019, is designed to handle 100 million passengers a year by 2025, with plans to expand to 200 million by 2040. It's the largest single-building airport terminal in the world, covering 700,000 square meters of floor space. The design is bonkers. British-Iraqi architect Zaha Hadid created a starfish-shaped terminal with 6 flowing concentric rings that look like something out of a sci-fi movie. The goal was to minimize walking distances. No gate is more than 600 meters from the center, which means you can get from security to your gate in about 8 minutes. Compare that to Beijing Capital Airport, where you might need 20 minutes and a Sherpa. China built this in less than 5 years. 5. For context, Berlin's Brandenburg Airport took 14 years and still had problems when it opened. Daxing went from groundbreaking to operational in the time it takes most countries to complete environmental impact studies. The construction involved 1.6 million cubic meters of concrete and 52,000 tons of steel. At peak construction, over 50,000 workers were on site. They worked in shifts, 24 hours a day, 7 days a week. The Chinese approach to mega projects is simple. Throw unlimited money, unlimited workers, and limited concern for anything that might slow things down at the problem. The airport sits 46 kilometers south of Beijing, connected to the city by a high-speed rail line that makes the journey in 20 minutes. Because China doesn't just build airports, they build entire transportation ecosystems. Daxing also features some genuinely impressive green technology. Rainwater collection and a geothermal system that reduces energy consumption by 12%. There are over 80,000 square meters of green roofs. It's probably the most environmentally friendly mega airport in the world, which is weird to say about something designed to handle 200 million flights a year. The price tag? About $17 billion for the airport and $11 billion for the supporting infrastructure. That's $28 billion total, and China considers that a bargain. Why did Beijing need another airport? Because Beijing Capital Airport was bursting at the seams. It's the second busiest airport in the world, handling over 100 million passengers a year. And it was designed for 80 million. The delays were legendary. The congestion was unbearable, so China did what China does. They built a bigger one. And when Daxing inevitably gets too crowded, they'll probably build another one. That's the advantage of not having to worry about things like environmental lawsuits, community input, or lengthy democratic processes. You just build. Daxing is a monument to efficiency, ambition, and the idea that if you have enough concrete and political will, you can build anything. It's also a middle finger to anyone who thinks airports have to be soul-crushing nightmares of endless corridors and overpriced food courts. Will it change global air travel? Probably not, but it definitely makes a statement. And that statement is, we're China. We build stuff. Number 1. The North-South Transport Corridor. Eurasia, all right. Let's end with a project that most people have never heard of but might actually reshape global trade for the next century. The North-South Transport Corridor, or NSTC, is a 200-kilometer multimodal transportation network connecting India to Russia via Iran and the Caspian Sea. It includes railways, highways, and shipping routes designed to move cargo between South Asia, Central Asia, and Europe faster and cheaper than existing routes. Why does this matter? Because right now, if you want to ship something from Mumbai to Moscow, it goes through the Suez Canal, the Mediterranean, and then overland through Europe. That journey takes about 40 days and costs a fortune. The NSTC cuts that to 20 days and slashes costs by about 30%. The corridor was proposed in 2000, but went nowhere for 2 decades because nobody could agree on funding, routes, or who gets to profit. Then 3 things happened. First, China's Belt and Road Initiative made everyone nervous about Chinese dominance of trade routes. Second, sanctions on Russia after Ukraine made Moscow desperate for alternative trade connections. Third, India realized that if it wanted to compete with China economically, it needed better access to Central Asian and European markets. Suddenly, the NSTC went from a nice idea to a strategic priority. The route works like this. Cargo ships from India sail to Iranian ports on the Persian Gulf, mainly Bandar Abbas or Chabahar. From there, goods move by rail or truck through Iran to the Caspian Sea. They cross the Caspian by ship to either Azerbaijan or Kazakhstan, then continue by rail through Russia to Europe. The project involves upgrading thousands of kilometers of railway, building new ports, improving customs infrastructure, and creating standardized procedures, so cargo doesn't get stuck at every border for weeks. It's less a single mega project, and more a massive coordination effort between countries that historically haven't been great at coordinating. Iran is the linchpin. The corridor doesn't work without Iranian cooperation, which makes Western countries nervous. India is investing heavily in Chabahar port specifically to have a trade route that bypasses Pakistan, their longtime rival. Russia sees the corridor as a way to maintain economic relevance, despite being increasingly cut off from European markets. Azerbaijan and Kazakhstan are just happy to be included and collect transit fees. The economic potential is enormous. The corridor could carry up to 15 million tons of cargo annually once fully operational. That's a significant chunk of India-Europe trade. It also gives landlocked Central Asian countries better access to global markets, which could boost their economies significantly. Construction is happening in pieces. India has invested over $500 million in Chabahar port. Russia is upgrading its rail networks. Iran is building new railway connections to the Caspian. But the full corridor won't be complete until at least 2030. The geopolitical implications are huge. This is India's answer to China's Belt and Road. It's Russia's lifeline to the global south. It's Iran's chance to become a transit hub instead of a pariah state. And it's a nightmare for anyone who benefits from the current Suez Canal route. Will it work? And that depends on whether these countries can actually cooperate, whether sanctions on Russia and Iran ease up, and whether someone doesn't blow up a critical section for geopolitical reasons. But if it works, the NSTC will be one of the most important pieces of infrastructure built this century. It won't be as flashy as a mirrored city in the desert or as sexy as a fusion reactor. But it will move goods, connect markets, and shift the balance of global trade. And that's worth more than all the megaprojects combined. So there you have it. 8 megaprojects that are either going to change the world or bankrupt the people building them. Maybe both. The one thing they all have in common? Ambition. The audacity to look at a desert, a mountain, or the laws of physics and say, yeah, we can do that. Whether they actually can? We'll find out soon enough. Thanks for watching.